Welcome to Subeezy, Subjects Made Easy. In this Math Principles lecture, we will discuss prime factorization. Let's begin by discussing what factors are. 12 is divisible by 1, 2, 3, 4, 6, and 12. Therefore, the numbers 1, 2, 3, 4, 6, and 12 are factors of 12. Factors must be integers. If x is a factor of y, then this means that x can be multiplied by some integer to equal y. For example, 3 is a factor of 15. If we multiply 3 by the integer 5, we get 15. And note that 1 is a factor of every integer. Now do not confuse the term factors with the term multiples. 24, 36, 48, etc. are multiples of 12. A useful mnemonic is the following: more multiples, fewer factors. You can go on listing multiples forever, but there is only a limited number of factors. So now let's discuss divisors. X is a divisor of y if we get an integer when we divide y by x. For example, if 32 is divided by 16, the result is 2. Since 2 is an integer, 16 is a divisor of 32. Note, if a number is a factor, it is also a divisor. If a number is a divisor, it must also be a factor. So 16 is a factor and a divisor of 32. We can consider the terms factor and divisor to refer to the direction. A factor means that x times an integer equals y, whereas a divisor means that y divided by x equals an integer. So the following are multiple ways to say the same thing. 2 is a divisor of 32. 2 is a factor of 32. 32 is a multiple of 2, and 32 is divisible by 2. So we said that the factors of 12 are 1, 2, 3, 4, 6, and 12. However, this only considers positive factors. -1, -2, -3, -4, -6, and -12 are also factors of 12. They are the negative factors. Therefore, the number 12 has a total of 12 factors, positive and negative. You will rarely be concerned with negative factors on your test. So now let's do some practice with factors. Find all the positive factors of 140. Start with the number 1 and move up. So 1 times 140 is equal to 140. 2 times 70 is equal to 140. 3 is not a factor. 4 times 35 is equal to 140. 5 times 28 is equal to 140. 6 is not a factor. 7 times 20 is equal to 140. 8 is not a factor. 9 is not a factor. 10 times 14 is equal to 140. 11, 12, and 13 are not factors of 140. And 14 times 10 is equal to 140. Notice that 14 times 10 has already been mentioned. We had 10 times 14. Notice that this factor pair, 14 times 10, is a repeat of a factor pair that we have already listed. When this happens, you have found all the factors. So now let's list all the factors of 140. 1, 2, 4, 5, 7, 10, 140, 70, 35, 28, 20, and 14. Now identify the factor pairs. These are the two factors that, when multiplied together, equal our number. So the number 140 has a total of 6 factor pairs: 1 and 140, 2 and 70, 4 and 35, 5 and 28, 7 and 20, and 10 and 14. So now that we have discussed what factors are, we're ready to discuss what prime numbers are. Prime numbers are divisible only by 1 and itself. For example, 3 is only divisible by either 3 or 1. 7 is also a prime number. It's only divisible by 7 and 1. And 19 is a prime number. It is only divisible by 19 and 1. Now you must memorize all of the prime numbers for less than 20, which includes 2, 3, 5, 7, 11, 13, 17, and 19. Now there are two very important principles about prime numbers. First, 1 is not a prime number. And second, 2 is the only even prime number. So now that we have discussed what factors are and what prime numbers are, we can now combine this and discuss prime factorization. Recall the factor pairs of 140. We had 1 times 140, 2 times 70, 4 times 35, 5 times 28, 7 times 20, and 10 times 14. When we multiply together 1 and 140, we get 140. The goal of prime factorization is to take this first factor pair, 1 times the number, and break it down into just prime numbers. So we have 1 times 140. Let's break down 140. 140 is equivalent to 2 times 70. So we can take 2 times 70 and plug that in for 140. We just saw previously that 2 is a prime number. So now let's break down 70 into prime numbers. We know that 70 is equal to 2 times 35. 2 is a prime number, but 35 is divisible by more than just 1 in itself, so it is not a prime number. 35 is equivalent to 5 times 7. So what we end up with is 1 times 2 times 2 times 5 times 7. We cannot divide these factors by any numbers. We have reduced 140 down to all of its prime factors. But what about the other factors of 140 that aren't prime numbers, including 4, 28, 20, 10, and 14? Well, let's take a look at the prime factors of 140. 2 times 2 times 5 times 7. By multiplying together these prime factors, we can find all other possible factors of 140. This is a very important principle for prime factorization. So for example, 2 times 2 is 4. 2 times 2 times 5 is 20. 2 times 2 times 7 is 28. 2 times 5 is 10. 2 times 7 is 14. 2 times 2 times 5 times 7 is 140. So now let's do some more practice with prime factorization. Find all the prime factors of 250. Now remember, you must memorize your prime factors for 2 through 19. So begin by writing down the number, 250, and begin by dividing this number by any prime number. Usually 2, 3, or 5 are the easiest to start with. So we will begin by dividing 250 by 2. We end up with 2 times 125. 125 is not a prime number. We can divide this by another prime number. Let's divide it by 5, which is a prime number. We end up with 5 times 25 is equal to 125. Now 25 is not a prime number. And we can divide this by 5, and we get 5 times 5. 5 is a prime number, so we are done finding the prime factors of 250. 250 is equal to 2 times 5 times 5 times 5. Or in other words, 250 is equal to 2 times 5 raised to the third power. Now let's find all the factors of 250. To do this, we just multiply together all of the prime numbers in as many possible combinations. So 2 times 5 is 10, 2 times 5 times 5 is 50, 2 times 5 times 5 times 5 is 250, 5 times 5 is 25, and 5 times 5 times 5 is 125. All the factors of a number are just different combinations of the prime factors multiplied together. And don't forget 1. 1 is also a factor of every number. So our total factors for the number 250 are 1, 2, 5, 10, 25, 50, 125, and 250. Now building off of this, let's discuss how to use prime factors to find the total number of factors a number has. Taking the prime factorization of a large number can be very helpful for finding the total number of factors of that number. For example, how many factors does 3052 have? 3052 is a very large number, so writing out all of the factors for 3052 might take some time. In order to make this easier, the first thing we should do is the prime factorization. So start with 3052 and pick one of the prime numbers. Recall 2, 3, or 5 are usually the easiest to start with. When we divide 3052 by 2, we get 1026. We can divide this by 2, we get 513. We can divide this by 3, we get 171. And we can divide this by 3 and get 57. 57 divided by 3 is 19, and 19 is also a prime number. So here's the prime factorization of the number 3052. Now in order to find the total number of factors 3052 has, the next step is to rewrite the prime factorization in terms of exponents. So 3052 is equal to 2 squared times 3 cubed times 19 raised to the power of 1. We have 2 2's, we have 3 3's, and we have 1 19 after we have found the prime factorization of 3052. Then take the exponents and add 1 to each. 2 is raised to the power of 2, 3 is raised to the power of 3, and 19 is raised to the power of 1. So we have 2 plus 1, 3 plus 1, and 1 plus 1. Or we have 3, 4, and 2. Then we multiply these values together. 3 times 4 times 2 is 24. So including 1 in 3052, the number 3052 has 24 total factors. So what if the question asked for only the odd factors of 3052? Again, if we didn't have a shortcut for doing this, finding all of the factors for a very large number would take a lot of time. You don't have a lot of time on your test. So to find only the odd factors of 3052, we can do the same steps, except ignore the prime factor 2. We want to ignore all even numbers. If we multiplied together anything by 2, we would get an even number. So we do not want to include 2. So we're going to rewrite in terms of exponents. This is the second step. We have 2 raised to the second power, 3 raised to the third power, and 19 raised to the first power. We're going to take the exponents and add 1 to each, but we're ignoring the 2. So we have 3 plus 1 and 1 plus 1. We have 4 and 2. Now we're going to multiply these values together. We have 4 times 2, which is equal to 8. 3052 has 8 odd factors. And if they asked you not for the odd factors, but for the even factors, then find the number of odd factors like we just did and subtract it from the total. There were a total of 24 factors. We found that there are 8 odd factors, so 24 minus 8 is 16. Let's do some more prime factorization practice. An unknown variable z is divisible by both 9 and 12. Which of the following is true? More than one may be correct. A. Z must also be divisible by 9 times 12. B. Z must also be divisible by 18. C. The prime factorization of z is 2 times 2 times 3 times 3 times 3. And D. Z is an even number. Let's start with A. To find all factors of a number, you must calculate every combination of the prime factors multiplied together. 9 and 12 are not prime numbers. So depending on the exact value of z, the statement may or may not be true. If z was 108, then it would be divisible by 9 times 12, which is equal to 108. But if z was 36, it would be divisible by both 9 and 12, but not by 9 times 12, which is 108. Therefore, A is false. Now for option B. If 9 and 12 are divisors of z, then we can continue to break them down into their prime factors. 9 is equal to 3 times 3, and 12 is equal to 2 times 2 times 3. A few of the prime factors of z must be 2 times 2 times 3 times 3. Note that even though we have a total of 3 3's, we are only including 2 of them. Because we do not know the value of z, it is possible that there is overlap between one of the 3's and 9 is equal to 3 times 3, and the 3 and 12 is equal to 2 times 2 times 3. Since the prime factorization must include 2 times 2 times 3 times 3, a factor of z can also be 2 times 3 times 3, which is 18. Therefore, B is true. Now for option C. If z was 36, then its prime factors would be 2 times 2 times 3 times 3. If z was 108, then its prime factors would be 2 times 2 times 3 times 3 times 3. Because 3 appears in both 9 and 12, then we must ignore one of the 3's, since it is possible we are counting for that 3 twice. This is what we just explained for option B. Therefore, C is false. And now for option D. Because 2 is one of the prime factors, z must be even. Therefore, D is true. And now let's go ahead and conclude this lecture on prime factorization with the key points. First, factors are integers that can be multiplied by another number to equal the number that you are considering. Second, prime numbers are numbers that can only be divided by the number 1 and itself. 1 is not a prime number, and 2 is the only even prime number. And third, prime factorization is the process of identifying all of the prime factors for a number. You can determine every other possible factor for that number by calculating all possible multiplication combinations of the prime factors. This concludes the Subeezy lecture. Thank you for watching, and be sure to do the practice problems.